AWARE is a European Framework 6 project studying the autonomous self-deployment and operation of wireless sensor-actuator networks cooperating with aerial objects. It pulls together the combined expertise of global corporations, SMEs, and leading research institutions from across Europe. The AWARE partners have recently carried out the second-year validation trial at a site in Spain. Here, more than 20 researchers and engineers participated in the experiments, during which several components and subsystems of the AWARE platform were successfully tested and demonstrated. The objectives of AWARE are to address issues relating to the communications between and cooperation of unmanned aerial vehicles with ground wireless sensor networks to enhance situational awareness in civil disaster and filming scenarios.
Okay, this is the last one to be dropped.
The AWARE unmanned aerial vehicles offer a low-cost, readily transportable alternative to larger platforms and provide an unparalleled versatility and level of accessibility. Wireless sensor networks are now being used in a wide range of applications, from monitoring of buildings and fixed infrastructure to applications where rapidly deployable systems are needed for the monitoring of evolving situations. Wireless sensor networks can house an almost endless range of sensors that could, for example, be used to monitor civil security and disaster scenarios such as building fires. In this example, the AWARE system can provide a wealth of information to first responders, from which they can make better informed decisions and may ultimately result in the saving of lives.
It's correct.
The AWARE 2008 experiments and demonstration required significant coordinated efforts for its preparation and execution, during which a number of aspects of the project were shown. Autonomous node deployment is one feature of the AWARE platform. It provides a means by which, once that an event such as a fire has been detected, and sensor nodes can be automatically deployed to the appropriate locations, either to obtain specific measurements or to establish communications connectivity in the network. Load transportation is a unique capability of the AWARE platform. We show the ability to transport loads by means of a single or multiple autonomous helicopters. The robotic helicopters are each capable of lifting and transporting loads such as supplies, first aid components, and communication equipment, by depositing them in the required positions that cannot be reached by humans or manned vehicles. By using multiple helicopters, the system is able to carry loads that would be too heavy for a single helicopter. Monitoring, where the measurements made by the nodes and the images obtained by the cameras on board the helicopters are displayed and processed on a suitable human interface. This provides the user with a unique ability to oversee the operation and gain insight into how the situation is evolving. The main features of the AWARE platform were presented to the reviewers and a contingent of end users that attended a demonstration on the final day of the experiments. Fire extinguishing. The network includes actuation nodes, such that a fire extinguisher installed on a fire truck can be pointed and activated automatically based on information provided by a UAV camera. A newly developed human interface is used to monitor the scenario. It includes images transmitted by both the ground cameras and those on board the UAVs. The field of view of these cameras and the position of all the AWARE components on the scene are displayed to the user. Tracking is another functionality demonstrated in AWARE. It is based on a probabilistic, decentralized, network-based tracking system that integrates measurements from the sensor nodes with the images, both from cameras on board the UAVs and on the ground. The combined information from these sources is used to track firefighters by providing in real time their positions and the uncertainties associated with these estimates. AWARE is able to autonomously plan, coordinate and execute flights of several autonomous helicopters and coordinate their activities for the joint purpose of monitoring or surveillance missions. During the trials, we were able to demonstrate the coordinated flights of multiple autonomous helicopters, cooperating to observe an event from different viewpoints. We expect the AWARE project to provide a number of innovative solutions to the problems of embedded control of UAVs, cooperation amongst different objects, and wireless sensor networks. The AWARE 2008 experiments proved to be an exciting opportunity and provided the consortium with information that will be useful in moving into the final year of integration and implementation of the platform. They also demonstrated the developments of functionalities that may eventually be used in applications of disaster management and filming.